Question for you. Imagine you had an honest coin and you flipped it 9 times and somehow you managed to get 9 heads in a row. What are the odds that the next flip, the 10th flip, will also be heads? My name is Adam Ross Nelson and I'm a data scientist. In the video ahead, I'll have an answer to this question. This channel is for current and aspiring data professionals who are looking to enter and level up in the field. If you think that content will be useful to you, I hope you'll click subscribe and also click the bell button so you'll find out when other videos become available. In this particular video, I'll be demonstrating that even after you flipped a coin, an honest, fair coin, 9 times and somehow miraculously ended up with 9 heads in a row, you still have a 50-50 odd of getting heads again on the 10th flip. Now this is an elementary problem for a lot of data scientists. However, if you're new to the field or you haven't looked at this material in a while, this will be a good refresher. Also, for anyone who's coming over to Python from a new language or not yet familiar with Python, we'll let this be a mini coding tutorial as well. For this demonstration, I'll be using a Google Colab Jupyter Notebook environment. The primary tool we'll use here is Numpy. We'll import Numpy as NP. This is a pretty standard import for the data science workflow. After that, we'll define a function that will make 10 coin flips. Essentially, it'll give us a string, 10 characters long, of either randomly t or h. We're going to use numpy.random.randint in order to get a number between 0 and 1. We'll say if it was a 1, that was a heads. If it was a 0, that was a tails. This particular function will return, as I've set the parameter, will return 10 flips, a string of 10 flips. Here in this subsequent cell, I'll take that function we just created. I'll use list comprehension to create 10 sets of 10 flips. Now that we have an efficient and convenient way to create any length of sets of 10 flips, let's create 1 million flips of 10. Now that we have a million sets of 10 flips, let's again use list comprehension, this time with a conditional, in order to extract all of the sets where the first 9 flips were all heads. Another aspect of this particular cell is I'm only listing out the first 5 examples. Now that we have a proof of concept in code that works, let's go ahead and store all of the examples where the first 9 flips were all heads in a new variable. Just for curiosity's sake, let's go ahead and see how many occurrences there were. Here we see the result is 1,950. So if you flip a coin 10 times and then you do that a million times, 1,950 or about 2,000 of the sets will be all heads for the first 9 flips. Nearing the end of this demonstration, where in fact I will demonstrate that the odds of getting a head on the 10th flip, even if the first 9 flips were all heads, is 50%. Here, I'm creating an array of zeros and ones. The ones will be representative of heads, and the zeros will be representative of tails. After creating that array, I can calculate the mean of that array. The mean of that array will be the proportion of positions which were equal to 1. In other words, the proportion of positions or the proportion of flips that were indeed heads. Here we end up with 0.48. I call that 50% odds. You can run this code on your own. You'll get slightly different numbers, but you're always going to end up somewhere near 0.5. The larger number of sets that you create, the closer you'll get to 0.5 in general. Thank you so much for watching this video. I hope you had a little bit of fun. I hope you learned something, and I look forward to seeing you in another video. Don't forget, you're more ready than you think you are. Hit subscribe, check out these other videos, and let's connect. I look forward to being in touch.